Good morning, friends. Now I'll discuss the electromechanical relay OCR1 and EFR1. The basic idea will give you its working, which is programmed in the microprocessor relay or numerical relay. First, see, we have OCR1 relay two elements, instantaneous and IDMT. In instantaneous, you have seen it has set to 25% more of the LV fault maximum current. That means during LV any fault, the instantaneous OCR1 will not trip. It will trip only a fault on the 132 kV with higher current. And then IDMT, OCR1 IDMT. IDMT is to permit the overloading. Our traction transformer is designed to withstand 200% overload for 5 minutes and 150% overload for 15 minutes. It is permitting that thing. And then earth fault relay. Earth fault relay is setting current is 10%. So when this 10% current will enter in the earth fault relay or more, it will trip the circuit breaker. So already we have seen the setting for 21.6 MVA power transformer with 132 side 400 by 5 seat ratio and 27 kV side is 1500 by 5. The load current, rated load current in the 132 kV side is how much? It is 163.6 ampere. I have done a mistake. The rated IDMT setting of the rated load current in 132 kV side is 190%. Then there is three-stage setting: stage 1, stage 2, stage 3. So all this for numerical relay, but we are following the in electromechanical relay is 25% more for instantaneous the rated load current, rated fault current in the 27 kV side, and IDMT set according to the calculation, it current possibly set at 150% of the rated load current, and earth fault relay is 10% of the rated load current. So now I'll show how it works. First, instantaneous overcurrent relay. How it works? Okay. When this situation will arise for a 21.6 MVA transformer, means rated load current 163.6 ampere, LV side maximum fault current 4600 ampere, reflected to high voltage side means 132 kV side 1309 ampere, CT secondary 16.36, and 25% more is 327%. When this situation will come, the instantaneous relay will act. So what we have seen, when the 25% more LV current reflected to HV side, that is 1309 ampere, but in CT secondary it is 16.36 or 327%. When this current will reach the CT secondary, will pass an instantaneous relay will energize and make its contacts normally open contact, and the positive will extend up to the trip coil, and the trip coil will open the circuit breaker. So this is the basic idea in electromagnetic relay, and this is programmed in the numerical relay. Next, this IDMT relay I will not show the same characteristics, but it is permitting overload. So that is program is given that current, if it will clear, this overload is clear within a certain period, that means to permit the transformer for 200% for 15 minutes and 150% load for 15 minutes, but if it is less than this time, then the CB will not trip, it will continue. Now I will show the earth fault relay. Let's see what it is. And how this earth fault relay will work. If any earth fault between CT to power transformer winding exists, leakage current will flow and it is close to the transformer primary, so it is harmful. So when it is more than the setting, that means current setting is 10%, and other setting I have already shown, it will reach or more, then the CB will trip. I have not shown the CB in the secondary side. Both the CB will trip through inter-trip relay to make dead the transformer. Now see, the earth fault, earth leakage is continuing. How? Friends, as there are two cities in the red phase and yellow phase, except earth fault between CT to power transformer winding, in all other case both the CT will carry same current, means incoming current is equal to return current in the primary, it will return to source. Power supply taken from the grid from through red phase, then it will return to through yellow phase, but both the CT will carry same current. But during any earth fault after the CT towards power transformer winding, source current, the current, it will be divided in the two return path. One is through earth, where the earth fault occurred, and another through the power transformer winding. So here is source current is carrying two types of current. One goes to earth and one goes to the transformer winding. So this defines this current in the cities. City secondary, it will take defines current. The red phase it will take the total city secondary current, but when it is coming, it will be divided into two parts. One will pass through the instantaneous IDMT coil, the total current, but it will be divided into two paths. After the IDMT, one portion will pass through the CT in red phase and another will flow to the CT in red phase through earth fault relay. Otherwise, earth fault relay will not carry any current except earth fault. It is the balancing system. So it is happening. As the source current divided into two parts, here it will be divided into two parts. One is the total current will carry the instantaneous IDMT, but earth fault relay will carry one portion, and if it is more than the setting of the relay, then the earth fault relay will trip both the circuit breaker. That means HB side circuit breaker, double pole circuit, and LB side single pole circuit breaker, and the transformer will be dead. It is dangerous near to the part of an earth fault. So it has been designed, and all these things is programmed in the microprocessor relay. Here we have taken two relays, instantaneous IDMT for overcurrent relay, but in microprocessor relay, the two cities output has given in the microprocessor relay, and they are doing all these things through the program. But in electromechanical relay, we have to design the circuit. But in microprocessor relay, we have to program the situation. Thank you, friends. Next day we will discuss other relays in electromechanical systems, so that the basic will be clear. Okay, thank you.